Hello everyone, Professor Vaibhav Shah here. Hope you have gone through all of my previous lectures of engineering graphics and also the lecture 1, Introduction to Engineering Curves. If not, then before starting this lecture, I insist you to go and check that first to understand the basic concepts and notifications to be used. This introduction lecture covers all the basic concepts like what are engineering curves and its applications in various engineering fields, understanding of conics with pictorial representation, classification of engineering curves, understanding of various engineering curves and its definitions and nomenclatures that we'll be using in our subsequent lectures. In today's lecture 10, we will be learning how to draw parabola by tangent method. If you like my content and teaching style, then share it with your friends and do not forget to like and subscribe to show your love and support. If you want to get better and in-depth knowledge about the subject, then I would recommend the latest edition of book by author Professor P.J. Shah, which is the standard book referred by engineers all over India. Let us begin. So now, first, step-by-step procedure to draw parabola by tangent method. To draw parabola by tangent method, what we require is first the base of the parabola and second the axis of parabola. So now, draw the given base as a horizontal line. So we can see this AB line is nothing but the base of the parabola by given dimension. Find out the midpoint of this line as point C. And after getting this midpoint, we'll be drawing the axis of parabola or height of parabola as CD. Now, after that, in step 2, we have to extend this line CD to get this point E such that CE, the total distance of CE must be twice the distance of your axis of parabola, which is CD. So remember that in this case, we have to take twice the distance of your actual dimension of the height of the parabola. So we have to take the twice the distance of your CD to get your point E. So this is nothing but 2 times CD as your point or distance between CE. After getting this point E somewhere here, you have to join this point E with your point A and E with your point B such that you will be having your isosceles triangle which is having EA is exactly equal to EB. After getting this isosceles triangle drawn, you will be dividing this particular line EA and EB into exactly same number of equal parts. And you have to compulsorily divide these lines into even numbers of parts only. So keep in mind that you will be dividing this particular portion EA and EB into even numbers of parts only. So let us divide this portion into 8 number of equal parts. We'll be starting from this point A as 0. So 0, 1, 2, 3, 4, 5, 6, 7 and 8. This point would be starting from here, point E as 0, 0, 1, 2, 3, 4, 5, 6, 7 and 8. So here which method we have used is a method which is known as a triangle method. If you don't know this method, refer my previous lecture. You will get an idea about how to divide this unknown length of your line into exactly equal number of parts. You can refer my previous lectures. Now, after dividing this line, in next step we will be connecting this point. Next step is very simple. We'll be connecting this 1 point with 1 point by a straight line, 2 point with 2 point, 3 point with 3 point, 4 point with 4 point, 5 point with 5 point, 6 point with 6 point. You have to join 7 point with 7 points. So we'll be joining each of the points by a straight line. So you have to join 1 with 1 point, 2 with 2 point, 3 with 3 point. You have to join 4 with 4, 5 with 5, 6 with 6, and you will be having diagrams something like this. After that, you will be having this diagram. You can see that the idea of your curve. So this is almost your parabola is generated. You can see that almost your parabola is seen here in this diagram. So you have to just join by the smooth dark line and the outer periphery of this tangents to get your accurate parabola. So after joining these outer periphery of these, all of these tangents will be having this final curve, which is nothing but your parabola. Now, you will ask, sir, why we have divided this portion into even number of parts only? So the reason is when we divide this portion into even number of parts, then the condition which is generated is from the center portion of this part, we'll be having one horizontal line. And if we try to find out this distance between this horizontal line of 4 with your C, it will be nothing but your actual height of your parabola or axis of parabola. So to double check your answer, we must divide this line into even parts to get this center line as a horizontal line, which will indicate you as your height of your parabola. So this is nothing but your parabola by given length of your base, and this is nothing but your given height of your parabola. So this is nothing but your tangent method. Note, the perfectness of the parabolic curve completely depends on the efficiency of the tangent points chosen by the user. So you require your accuracy in drawing. If you are not so accurate, you have to practice 2 or 3 more times to get your parabola exactly which is shown in your figure. So now let us begin with some example based on this tangent method. So first example, problem number 1. Draw an isosceles triangle of 100 mm long base and 110 mm long altitude. Inscribe a parabola in it by method of tangent. So we have to use here tangent method to draw parabola. So here remember that we have already given with the isosceles triangle. That means your isosceles triangle is having base 100 mm long base and height of this triangle is 110 mm long altitude. Here note that this 110 mm long altitude is not the altitude or height of your parabola, but this is your height of your isosceles triangle. So we have to draw first the isosceles triangle of 100 mm base and height of 110 mm. So for that you will construct your triangle with 100 mm base. So first of all you have to draw 100 mm long line. After that you will find out its midpoint somewhere here at 50 mm, and after that you have to draw one vertical line of 110 mm, and at the end point you will be having this end point of your triangle, and after getting this end point you will just simply join this end point with your base end points, left hand side base end point and the right hand side end point to complete your isosceles triangle. After that let us give these points naming as A and B and this top point as your C point. After that we'll be dividing this portion AC and CB into exactly equal number of parts, and you have to divide this into even number of equal parts. So let us divide this portion into equal number of equal parts. So we have divided this portion into equal number of equal parts. Likewise we have divided this portion also into equal number of equal parts. So we have divided this portion into 40 number of equal parts. Likewise we have to divide this portion also into 40 number of equal parts. After dividing this part, the main thing is to give numbering. If you have given the wrong numbering pattern, you will be having wrong curve. So mind that your numbering pattern is very much important in this method, tangent method. So let us observe this numbering pattern. So we'll be starting numbering from this point A as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Now for this line we will be starting numbering from this point C as 0.0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. After that, next step is very easy. We will join one point with one point. So let us join 1 with 1, 2 with 2, 3 with 3, 4 with 4, 5 with 5, 6 with 6, 7 with 7, 8 with 8, 9 with 9, 10 with 10, 11 with 11, 12 with 12 point, 13 with 13 point, and 14 point is already connected with 14 point. After that, we'll just simply join this outer periphery of your tangents to get the smooth curve, and simply join another outer periphery. So as you can see this profile of parabola already traced out by this tangent point. So you have to just completely highlight this parabola by a dark line. So you will start joining from your point A on the inner side of this profile traced out by this line. So let us join this by a dark line and you will have this parabola. This is nothing but your parabola which is having your 100 mm long base, and the axis or height of the parabola in this case would be half the height of your altitude of your isosceles triangle, which is here 55 mm. So this is your altitude of parabola. If it is asked in your examination what will be the height of the parabola, then you can find out, measure this vertical distance of your parabola from the center point of your AB and this will be your 55 mm, and this base is obviously given base which is of 100 mm. Let us see one more example. Draw an isosceles triangle of 100 mm long base and 120 mm long altitude. Inscribe a parabola in it by method of tangent. So once again we have to use the tangent method to draw parabola, and here once again isosceles triangle dimensions are given 100 mm and 120 mm long. So here once again this is not the altitude of your parabola, but this is the altitude of your isosceles triangle. So let us draw isosceles triangle first. So we'll be drawing horizontal line of your base, and then after we have to find out this point, center point O, and from this point O you will be drawing one vertical line which will be of 120 mm altitude, and you will be having this final point as your point C. After getting this point C, you have to just join this point C with your point A on the left hand side and point C on the B, connect this point C with your B on the right hand side. After finishing this isosceles triangle, you have to divide this particular portion of A to C into some equal number of parts, and this part should be in even numbers. So in this case we are dividing this portion into 12 parts in this case. So let us start numbering from this point as 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. And this part portion here will be starting from 12 number itself. So 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. After that the procedure is very simple. You have to connect this 11th part with this 11th part by straight line, 10th part with 10th part, 9th part with 9th part, 8th part with 8th part, 7th part with 7th part, 6th part with 6th part, 5th part with 5th part, 4th part with 4th part. You have to join this 3 number with 3, 2 with 2, 1 with 1. After getting, you can see that completely the profile is traced about this parabola. So you have to completely you have to use your pencil and draw a dark curve to highlight this profile traced out by these points, tangent points. And after that you have to mark this point P12, P11, P10, P9, 8, 7, 6, 5, 4, 3, 2, 1 and P0. If it is asked that what will be the height of the parabola, so we have to first identify this point is the top point as a vertex point, and we have to measure the distance of this point 0, which is the center point of your base, to the vertical vertex point V. And if we try to measure this distance, this will be your 60, and this is the half the distance of your complete altitude of your isosceles triangle. So you can write down your height of your parabola as 60, and the base is obviously given base which is of 100 mm. So let us see one more example. Draw a parabola with 75 mm long base and 45 mm long altitude by tangent method. So in this case we have given the dimension of parabola itself. Here the dimension of isosceles triangles are not given. So parabola with the base having base 75 mm long, that means we will be having horizontal line of 75 mm, and the height of parabola would be 45 mm long. So here this height is height of the parabola. So understand, many times student gets confused, so always understand what we are talking about. So we are talking about parabola. So this is the height of the parabola, not the height of your isosceles triangle. So draw the triangle with base AB and axis double the altitude of your parabola. So here the base is given as 75 mm and axis is given as 45 mm. So we have to take the twice the axis or double the dimension of your axis. 2 into 45, 90 mm. So first we have to draw one horizontal line of 75 mm and mark this as point A and B. After drawing this horizontal line, we will be identifying its center point O. So this is nothing but your center point O of your base. After getting this point O, we will be drawing one vertical line which is twice the dimension of your height of your parabola. So if your height of parabola here is 45, so we will be taking twice the dimension which is 90 mm. So we have to draw a vertical line of 90 mm to get this point O. So this is nothing but your OO, the axis of your isosceles triangle. After getting this point O, you have to just connect this point O with the A point on the left hand side, and you have to connect this point O with the B on the right hand side, and you have to complete this isosceles triangle. After that, we have to divide this portion of OA into exact number of equal parts as that of your OB on the right hand side. So remember that we have to divide this portion, this line, into always even number of equal parts. So let's say in this case, we are dividing this particular line of OA into 10 number of equal parts, and we'll be starting numbering from this point A itself as point 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. After that, we'll be starting from this side from 0 here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Next procedure is very simple. We'll be connecting or joining the same points. So we'll be joining 1 point with 1 point by straight line, 2 point with 2 point by straight line, 3 point with 3 point by straight line, 4 point join with 4 point, join 5 point with 5 point, join 6 point with 6 point, join 7 point with 7 point, join 8 point with 8 point, join 9 point with 9 point, and we'll be having profile traced automatically. You can see your profile is traced out by these lines itself. So you have to now, next step, you have to use your pencil and you have to draw dark smooth line. So starting from your point 0 in the inside of this profile traced out by this point. So if we try to trace out this point by a dark line, we can have this profile generated, which is nothing but your required parabola. And if we try to measure the distance between this top point, which is known as your vertex point now, so specify this point as your vertex point B, and try to measure this vertical distance of V to O, which is nothing but your 45 mm, and which is your required altitude of your parabola. So this is your required parabola with 75 mm as a base and 45 mm as a height. So this is all from my side. I will be putting down the link in description box below. You can go and check it anytime to learn any specific topic you want. And if you want to learn any other specific topics or facing other difficulties of understanding any topics or concepts, feel free and comment below. I am personally giving attention to each of your comments and will try to reply on your queries almost instantly. Do not forget to share it with your friends and like and subscribe to show your love and support. Keep learning, stay connected. Bye-bye.